Alright, today I'm going to talk about one of my absolute favorite molecules on planet Earth and answer a commonly asked question that kind of leans with some controversy. Alright, the topic is carbs. Carbohydrates are an organic compound that our bodies use for quick, reliable, really fast energy. That energy comes from the sugar molecules, glucose, that go through a process that ultimately makes ATP. ATP is like a battery that our bodies use to power reactions like muscle contractions or brain activity. All of the things really that our body does relies on ATP. ATP comes from sugar, glucose. Okay, this is a super important molecule, and it's really easy to find as it occurs in loads of food. For example, I absolutely love carbs. They taste great. They provide you with a ton of energy, and they're actually good for you.
Hold on. Just a minute there.
Sure. Okay.
I'm gonna have to interject. Gonna have to interject because these are not good for you. No, these are sugars. They're carbohydrates, right? Sugars turn into fats.
Sounds extreme.
They turn into fats. Well, it is extreme. It is extreme.
Okay, well, how about this? How about we table the discussion? I keep doing the video.
Okay.
And we'll come back to it.
We will. We will come back.
All right. Oh,
All right.
okay. All right. Thank you. Thank you. All right, let's take a look at the science behind all of this. All right, so now we will jump into the science and see how in some cases sugar does turn into fat. Okay, so let's jump into it. Sugar and fat, or sugar and lipids. Okay, sugar and lipids are both made of the same elements, carbon, hydrogen, and oxygen. So right away, just that alone, this kind of telling me that, yeah, sugar could turn into fat. Now let's look at how our body processes sugar. So the sugar that's in this isn't the sugar that our body uses. So we have to convert this into glucose. Glucose is a monosaccharide, which means it's a simple sugar. Our bodies use glucose to make ATP. ATP, as you may know, is a molecule that's kind of like a battery. It's the battery that essentially powers all of the cellular processes in our body. Everything from muscle contractions to brain activity to digestion, we need ATP. And so for that case, we need glucose, which is sugar and carbs. Okay? So when we have enough glucose to make the ATP that we need, our body will then take the glucose and do something clever with it. It will turn it into glycogen. Okay, glycogen is a storage molecule, and this is then stored for later use. Okay, so it's stored in muscles actually. And stored in muscles, it's stored near vital organs so that we always have energy ready to go when we need it, even if we haven't eaten for a couple hours or even a couple days. Okay, now here's where we run into problems. If we've made enough ATP, or we have enough glucose to make the ATP that we need, and we've filled up all of our storage areas in muscles and near our organs, and we're still putting sugars and carbs into our body, we have to figure out what we're going to do with all of this excess. Evolutionarily, our bodies are designed to store things because in ancient times we had to hunt and we had to gather and we had to grow our crops and we had to rely on the planet. But now I could just magic a donut into existence. Okay, so yeah, we now have this issue where we have too much glucose. We've made enough glycogen, we have enough to make ATP, so now we have to do something else. Glucose is going to go through the process of glycolysis, and that will result in a pyruvate. And in the mitochondria, well, you might be thinking now, isn't this the same process to make ATP? Yeah, it kind of is. The mitochondria will then make a chemical called acetyl-CoA, is usually used to power the Krebs cycle to make ATP. But instead, acetyl-CoA is going to be what we use to synthesize triglycerides or monoglycerides, these lipids. The problem is that acetyl-CoA is too big to leave the mitochondrial matrix, and so it's broken down into two chemicals. Those chemicals are oxaloacetate and citric acid. These two chemicals are small enough, they leave the mitochondrial matrix together, so they'll come back out into the cytoplasm where they reform a new acetyl-CoA. This acetyl-CoA that we now have outside of the mitochondria is then what is converted into triglycerides, and triglycerides are then put into storage where hopefully we use them when we need them. So now we've created a form of long-term storage that isn't going to be used right away, but when we need it, when we run out of ATP, when we run out of glycogen, now we have a backup reserve of storage. And this is where it all gets dumped. If we continue to put sugar in our body, we have glucose, it goes through this process to make these triglycerides or monoglycerides that are put into storage. And when we run out of places to store all of these lipids, then they end up going to places that maybe we don't want them to be. So in all, yes, sugar does turn into fat under really specific circumstances. So you can rest assured that if you want to just take a bite and just enjoy some sugars every once in a while, you'll be all right. Just don't make the mistake of keeping them coming in all of the time, because then they do turn into fats. And with that, that's Virtual Friday. See you next time.